In our first example of a two-dimensional problem where we're looking at motion, we just have a simple displacement problem where you travel 62 kilometers in a direction 60 degrees east of north, and then turn in a direction of 50 degrees south of east and travel an additional 23 kilometers. And the question is how far, so what is this displacement here? And in what direction are you from your starting point? So the direction would be this angle theta right here. Okay, so what we're going to want to do is we need to split up our displacements into their component parts. So we have our 62 kilometer vector. Let me make this a little thicker for you guys so you can see it easier. Okay, so here is our 62 kilometer vector, and we know that this was a 60-degree angle with horizontal, or a 60-degree angle from due north. Wow, from due north right here. So we know that that was 60 degrees. So if we wanted to figure out what the angle was from horizontal, that would be 30 degrees. Okay, I kind of like being consistent with doing angles from horizontal because then your x component of your vector is always cosine and your y component is always sine. You can use sine here if you use that 60-degree angle. I'm going to say, well, I know that this whole angle here is 90 degrees. If this is 60 right here, then this is a 30-degree angle from due east. Okay, so that would mean that my x component of this 62 kilometer vector I can find with cosine. So cosine of 30 is going to equal x over 62. So that x component is going to be 62 cosine 30. Okay, and then I have my, oops, this was 23 kilometers. I didn't label it clearly. So 23 kilometer vector. Okay, this is an angle with horizontal. I know that that's 50 degrees. So my x component of this vector is also going to be, I'm going to use cosine. Okay, so cosine of 50 equals this x component that I'm trying to find, x over 23. So 23 cosine 50 is my other x component. Okay, so let's just call, so we can distinguish between the two parts of the trip. We'll call that part A of the trip, and this will be part B of the trip. Okay, so our x component of our displacement vector that we are trying to find, so is going to equal 62 cosine 30 plus 23 cosine 50. Okay, so we know our x component. Now let's take a look at finding our y component. So if we were trying to find the y component, so this y component here, this y component here, now we're opposite of that angle, so we're going to use sine. So here we would have the sine of 30 equals y over ya over 62. So this y component of our first vector, displacement vector, is going to be 62 sine of 30. And if we take a look down here, this solving for y of b, we're opposite again. So sine of 50 is going to equal yb over 23. So our yb equals 23 sine of 50. Okay, and so now we have both of those vectors. One thing you want to note, our yb is in the negative direction. So you must put that negative sign there. So negative 23 sine 50. Yeah, so I like to visually look at, okay, I see that this is in my negative, my north is going to be my positive direction here. My east, I didn't put my arrows, is my positive direction here. So if I'm going, the component of my second part of this trip, the b vector, is going in the negative direction, so I need to add that negative sign out front. So in order to find my y component of that displacement vector. I'm going to take 62 sine 30 minus 23 sine 50. Okay, so now I have my two components, which we know if we know two components. So this is my dx and my dy. I know that dx squared plus dy squared is going to equal my overall displacement squared, okay, from Pythagorean theorem. So I'm going to take the square root of my dx value. And before we plug it into there, let's go ahead and go down here and figure out what those angles or what those displacements are. So dx 60, if we take 62 cosine of 30, that gives us 53.7 kilometers. And we're going to add to that, this gives us 23 cosine 50 is going to give us 14.8 kilometers. Okay, so we add those two together, and then our dy will be 62 sine 30 is going to be 31 kilometers, 31.0, and we're going to subtract from that 17.6 kilometers. Okay, so over here we get 68.5 kilometers squared plus 13.4 kilometers squared gives us a value for d, that's going to equal d. So that gives us a value for that displacement from the starting spot of 69.8 kilometers. Okay, so that was our d value here, or displacement from the starting spot. And now we want to find that angle. So our angle from our triangle here, well, so we can use tangent because we know dy and dx. So the tangent of that angle above due east is going to equal dy over dx. So we're going to get theta by taking the inverse tangent of dy, which is 13.4, divided by dx, which is 68.5. And that gives us 11.1 degrees. Okay, so there is our answer. We're not quite done if we just say 11.1. We want to say 11.1 degrees north of due east. North of due east. Okay. Let's take a look at a second example here. So here we have a woman that's swimming from a dock to a small island, and the island is 225 meters from the dock. When the water's calm, she can swim to the island and back in 15 minutes, but later the wind usually becomes strong, causing a current that runs from left to right, as shown right here. In strong wind, the velocity of the current reaches 1 meter per second. With this current, it takes Britta 15 minutes just to arrive at the island. And the question is, at what angle and with respect to her path in the calm water, and how much faster does she need to swim to reach the island in 15 minutes with the current? So if she was swimming like she would in calm water, just straight towards the island here, okay, with the current, that's going to veer her off course, right? She's going to end up going at some angle to the right if she was to like face forward and just swim forward. Okay, so in order to reach the island in 15 minutes, so basically the question is, what angle does she need to swim at in order to end up with a vector that's basically pointed straight at the island? Because she's going to have to swim in this direction. Wow, swim. She's going to have to swim somewhat into the current, right? Because that current is going to push her to the right. Okay, and she wants to end up going straight to the island. Okay, so we are trying to find this angle here that she needs to swim at with respect to the straight swim, and with what velocity she needs to swim at in order to reach the island in 15 minutes. So here, instead of adding two vectors together, we kind of know the resultant vector that we want. This velocity here, she wants to swim 225 meters in 15 minutes. Okay, and we probably want meters per second instead of meters per minute. So we know there's 60 seconds in 1 minute. So we get a velocity of 0.25 meters per second that she needs to swim at. So that, or swim at directly towards the island in order to get there in 15 minutes. But we know that that's not the actual velocity of her swim because she needs to swim kind of like into the current in order for her overall net displacement to go straight towards the island. So the question is, we want to find basically the magnitude and direction of her swim into the current, the 1 meter per second current, because the sum of those two is going to equal that resultant v vector, okay, of 0.25 meters per second. So let's go ahead and break this into vectors. Let's call this direction the y direction towards the island, and this can be the positive x direction. So we were going to want to split up our swim velocity vector into the current, into the x and y components. The resultant vector that we're going for just has a positive y component equal to 0.25 meters per second. And our current just has an x component of 1 meter per second. So we know the vector sum of v swim. Okay, so v swim x minus, well, this is negative, right? Because this is in our negative x direction. So negative v swim x plus 1 equals, well, our vector sum is not going to have any x component. She wants to go like straight at the island, so that's going to equal 0. So we get that 1 is going to be the x component of that vector, and specifically we're meters per second, 1 meter per second, because these are velocity vectors. So that's summing our x components of our vectors. Now we want to sum the y components. So summing the y components, well, we have our v swim y right here is going to just be equal to the y component, which is 0.25 meters per second. So we know that y component of v swim, so v swim y, has to be equal to 0.25 meters per second. And that's because this just has a y component. Okay, so we're making progress. We now know that the x component of that vector is going to equal 1 meter per second. And we know the y component has to equal 0.25 meters per second. So now we can find the overall v swim, okay, or the overall velocity vector is going to, using Pythagorean theorem, we know 1 squared plus 0.25 squared is going to equal the square of that. So we can take the square root of 1 squared plus 0.25 squared. And we take the square root of that, and we round to 1.0 meters per second. Okay, to find that angle. Okay, so this angle right here that we're finding. So the tangent of that angle is actually going to equal v swim x over v swim y. So we get 1 over 0.25. Okay, so the angle is going to equal, tangent is 1 over 0.25, which is going to give us 76 degrees.